Hi everybody, we are going to be talking about rational functions. Now, there's quite a bit in this section, so we're going to go over the basics and then leave a lot of the examples for in class. So, a rational function is formed by two polynomials. So it takes the form of p of x over q of x, where both p and q are both polynomials, but q of x does not equal 0. So here are some examples of different polynomials that we are going to be looking at. And so with this, we are going to have different asymptotes. So vertical asymptotes, again, these are going to be x equals 0. Vertical asymptotes have to do with the denominator. So we set the denominator equal to 0, or not equal to 0. So in this case, for example 3a, we're going to take x squared plus 2x minus 8, set that not equal to 0. This works just the same as if we set it equal to 0, so we would still want to either use our quadratic formula or factor. This one factors nicely into x plus 4, x minus 2. So this means that we would have the vertical asymptotes of x equals negative 4 and x equals 2. Now, this also helps us find our domain, but when we're talking about rational functions, we also need to find all of our asymptotes. So our vertical asymptotes actually help us with the domain. And so we know that our domain is going to be from negative infinity to negative 4 union negative 4 to 2 union 2 to infinity. So then if we look at part B, again we're going to set our denominator of x cubed minus 5x not equal to 0. We can factor out an x, so we have x squared minus 5 does not equal 0. At this point you can set x squared minus 5 equal to 0, or we can factor this to be x plus square root of 5 and x minus square root of 5. And so then our asymptotes, we can't forget that this x on the outside, we also have to set not equal to 0, so we would have a vertical asymptote at x equals 0, x equals negative square root of 5, and x equals square root of 5. And so again, our domain is going to be from negative infinity to infinity without these three values. So again, we have to think about this in numerical order. So this would be from negative infinity to negative square root of 5, union negative square root of 5 to 0, union 0 to the square root of 5, union square root of 5 to infinity. So that's for our vertical asymptotes. Our horizontal asymptotes are dependent on the degree that we have and the coefficients written in front of our leading terms for both polynomials. So when the numerator and denominator have the same degree, so this would be like if we had a of x to the n over b of x to the n, so it's the same number, then our horizontal asymptote is going to be y equals a over b. So we just take those coefficients of our leading terms and put them over each other, and it's going to be y equals a over b. Again, this is when we have the same degree polynomials, if the degree in the numerator is smaller than the degree in the denominator, so if we have, then we're going to have y equals 0. So that would mean our x-axis is our horizontal asymptote. And then if our degree in the numerator is larger than the degree in the denominator, this means that we're not going to have a horizontal asymptote, but an oblique. And we'll talk more about oblique asymptotes in class. So if we look at these examples, if we want to find our horizontal asymptote, we first need to look at the degree. So we're just looking at our first terms. In this case, our degrees are the same. They are 4. And so our horizontal asymptote is y equals -7/11. Now in this case, for example 5, we have that the degree is 1 is less than 3. So this means that we're going to have a horizontal asymptote at 0. Now for example 6, we want to find all asymptotes. So this means horizontal, oblique, horizontal or oblique, and our vertical asymptotes. So for our horizontal asymptote, again we look at our leading terms. We have the same degree, so 2 equals 2. So that means that y is going to be equal to 2/1. So we have a horizontal asymptote of y equals 2. And then we're going to set x squared not equal to 0 for our vertical asymptote, which just means that our vertical asymptote is x equals 0. So again, we're going to leave vertical or oblique asymptotes for in class. And so when crossing asymptotes, we can sometimes cross horizontal, but we will never cross verticals. Never crosses. And so we put all of this information together in order to help us to graph these, but we will actually graph the remaining of the examples just in class. So you can go ahead and stop watching because we're going to do the graphs in class and this application problem. Have a good day.